Alright, silly people, here's the situation. This time we're going to be making a IMSHO plot of the Mandelbrot set, or Mandelbrot set, I really don't know how it's pronounced, which is a fractal that is just determined by this equation here. You basically take a complex number on a grid of x versus y, and you make the complex number x plus iy, and you start with z equals 0, and then you run it through this iterative equation, z equals z squared plus c, a bunch of times. And if it ever comes to z being greater than 2, then you kill it and it's no longer in the set, but every value of z that stays within the set is considered part of the Mandelbrot set, right? So Newman is telling us to use a grid of x equals -2 to 2 and y equals -2 to 2, um, and then try iterating 100 times to see if it stays within the set, and then plot the result over, x versus y. So we're going to need matplotlib, so let's import matplotlib. Realized after recording last video that I've been importing pylab, which is actually a deprecated version of matplotlib. Instead, you want to do pyplot. So there's that. And then we also are going to need numpy because we're going to be dealing with arrays. So we're keeping that. Okay. First thing that I'm going to do is I'm going to create an array of x values. It's going to be called lowercase x. And this is just to represent the domain of the graph. You know, it goes from -2 to 2, and it has 100 points for now. And then same thing for y. NumPy and then space -2 to 2, 100 points. Now I'm going to do a NumPy function that's called meshGrid, where you create two different variables, which I'm just going to call capital X and capital Y. Yeah, and so these are going to be equal to the NumPy meshGrid, and then you call X and Y, right? This is kind of just to make an array of X and Y, and all the values in between those, so that we can do this next thing, which is C equals, and then this is going to be X plus 1j times Y. This is effectively the grid of complex numbers that we're going to run our Mandelbrot set checking through, right? And so we need to create an array of z's to run the equation through. So this is going to be z, and then they start off as zeros, and you have to use the numpy zeros like function, not the numpy zeros function, because the maximum size of the zeros function is only 64. We need ours to be like 100 or so. So call numpy zeros like c, and then this is going to be our output array, which I'm going to call Mandelbrot. It essentially just has to be a array of booleans, right? Because the problem statement is asking us to make it so the plot is black if it's inside the set and white if it's outside. So we can create an array of ones, numpy.ones, that is the same shape as the number of complex numbers we're checking through. So numpy, or c.shape, right? Shape. And then we specify that it's going to be a Boolean type array. So you use dtype.bool. That way it just fills an array that's the same size and shape as C, but full of statements that say true, and then we'll check if they stay true for every value, and at some point we'll make them false if they diverge. So that's where the for loop comes in for n in range 100 like Newman said, we're just going to check 100 times to see if it stays within the set. So z equals z squared plus c is the equation that we're iterating over. And that's going to do every element of the z array simultaneously. So that is really kind of cool. Then we create another Boolean that is just called out. That is going to create all of the indexes where the Mandelbrot equation diverges and is going outside of greater than equal to 2, right? So yeah, it's an array of Booleans, and it gets the indexes that we need, and I need to specify the absolute value. Yeah, that's what we're checking, the mod 2. And then we take our output array and we index every time that it fails, so every time it diverges, and you set that value equal to false, so that whenever it comes back, it will print the false ones in white, because we're going to use the imshow function from matplotlib with the Mandelbrot or Mandelbrot array as our output, with the CMap of binary. That way it does black and white, and I'm really bad at spelling Mandelbrot. But yeah, lots of complicated stuff in there, but it gives you a really low-res version of the Mandelbrot set, or Mandelbrot set. So I can see that it's overflowing a little bit, because whenever it diverges, it really diverges. The numbers get quite big quite fast. So what we can do is we can create an if out statement, or we'll index all of the outs stuff and set it equal to 2, just so it iterates over 2 and again and again, and it doesn't ever go to infinity, and it fixes the runtime. So that's nice. And then we can make it a higher fidelity just by increasing the sample size of x and y. So if I increase both of those to 1,000, now we have a pretty high fidelity fractal, which is pretty nice.